A synthesis reaction is when two or more elements combine to form one thing. This lab is about a synthesis reaction, specifically about the reaction of magnesium and oxygen. Now, this next picture shows a strip of magnesium before the reaction. Using a pseudo-Bunsen burner, we put the magnesium over the flames. The heat is adding oxygen to the magnesium. The bright light seen here is the reaction of magnesium and oxygen. Then, the magnesium oxide becomes brittle and falls apart.
Decomposition is when a compound breaks into two or more simpler molecules. An example of a decomposition reaction is when water or H2O breaks down into hydrogen and oxygen. Now this is an incomplete and unbalanced reaction because oxygen is a diatomic element, meaning it needs to have another oxygen or another element like hydrogen as it was at the beginning, needing to be by that. To solve the problem of oxygen being a diatomic element, another H2O compound needs to be added into the equation, thus balancing and making it into a complete chemical reaction.
A single replacement reaction is when an element replaces either the cation or anion of the compound. The replacement can only take place by the charge of the element on the activity series. The red Lego bricks represent magnesium, the blue represents chloride, and white represents calcium. Because of the activity series, calcium is higher than magnesium, so it can be replaced. Thus, the magnesium switched places with the calcium. This type of equation is already balanced.
For double replacement, we started with the equation Na3PO4 plus ZnSO4. And we'll have to do a crisscross method, but we'll get to that part in a minute. And now to finish the equation, this yields to Na2SO4 plus Zn3 in parentheses PO4 2. Now, for the crisscross method, you have to take Na and put its valence up, which is positive 1, and SO4, which is negative 2. And to crisscross, you have to multiply them. So Na is only 1, so 2 times 1 is 2, and 1 times 4 is 4. So that stays the same. And now for zinc, zinc's valence is 2, positive, and PO4 is negative 3. And when you cross that, 1 times 3 equals 3. And PO4 is in parentheses, so the 2 just goes on the outside. And now we have to rewrite the equation so that it's all ordered out so we can start balancing it. So now we have Na3 PO4 plus ZnSO4, which yields to Na2SO4 plus Zn3PO4 2. Now, to balance them out, you have to look at the equations and make sure that there's the same on each side. So we need a 2, a 3, another 3, and nothing there, and that is how you solve it.
South Lyon East High School, and I was asked to come here today to convince you that you should stay in school.
Okay? Well, I'm a science teacher, and there's a lot of fun things about science. You're probably in elementary school or middle school, and you might like science, and you do a lot of fun things. But let me tell you, it's nothing like you're going to do when you get to high school and get to participate in chemistry class. So we're going to learn, you probably already know about the different states of matter, solids, liquids, and gases. We do a lot more with those states of matter when we get to chemistry. So liquids, I've got some liquid here. I'm going to use some gas. I'm going to generate some bubbles. I'm going to do a demonstration for you that are called methane bubbles. Okay? This demonstration, while I'm talking here, I'm going to generate some bubbles in my little solution here. So I'm going to go off camera here for a second, and you're going to see some bubbles forming. When you get to chemistry, you learn a lot about some different types of reactions. And one of the reaction types that you're going to learn about is the combustion reaction. Now, you've probably heard about combustions in automobiles, where you combust gasoline in an engine to produce energy that makes your car go. And your gas furnaces at home actually combust gas to give you heat that heats your homes. Well, today I'm going to demonstrate a combustion reaction right in front of you. Okay, this is called methane bubbles. I'm just generating some methane bubbles right now. So that looks to be enough, so I'm just going to come over here and turn them off. Now, when we have a combustion reaction, we have to have what we're going to combust, which is the gas inside these bubbles, and we need an ignition source. So what I have is just a lighter here. I have some methane bubbles. I'm going to ignite them. Okay, so here we go. Okay, that is an example of a simple combustion reaction. All right? That is something that you probably won't see in elementary school or middle school, and you won't understand the details of that reaction right now. But all I can say is be cool, stay in school, and someday you can join into chemistry class and you can understand what goes on in that demonstration.